Hey guys, welcome to MathCube. Today we are going through the third question of the International Advanced Level Pure Mathematics of P3 from Jan 2021. So without further ado, let's get started. The A part has a sum function here, and it says that show that f of x equal to ax plus b upon cx plus d, where x is greater than 4. Okay, where a and b, c and d are integers to be found. Okay, so they say this big function here, let me just highlight it. This big function here is to be written in this way, so it's being simplified, so we have to simplify and then write it. So what I'll do is I'll just, so if you notice something, that we have first degree polynomial here, first degree polynomial here too, also here, but here we have a second degree polynomial, and that's a quadratic function there. So what we can do is we can just simplify and make it into first degree. So you can even do that by using your calc, just to save your time. So I'll be just plugging in the values here. Go for the equation function, third one, that's for quadratic. And now we'll just plug in the values. That's 2 here, minus 3, remember the signs, and that's minus 5. Let's press equal again, and I get one value of 5 upon 2. Okay, that's 2.5, and minus 1. So it's equally important to know that how to write this in the bracket function. So I'll just show you how. There you go, that's how it's written, 2x minus 5 and x plus 1, and if you set it to equal to 0, we'll get 5 upon 2 as our x first value of x, and x minus 1 as second value, as you have seen. So what I'll do is I'll just write this whole f of x again with this first degree polynomial. There you go, now I've written in the first degree polynomial form. Now that we have 3 minus x minus 2 upon x plus 1, first things we can notice is get out the LCM here, and we can already see that LCM will be x plus 1 and 2x minus 5. That will be our LCM. So what we can do next is we can multiply everything with this LCM, so that we get something like, there you go, we'll get something like this. Okay, now what I'll do is I'll just expand the bracket and multiply it with 3 here, and then do it the same here but using FOIL method, and we can already see the third one, 5x plus 26, is already written in this form, so we have to do nothing, and the LCM has been done. So now let me just expand it. There you go, I get this upon expanding the brackets. Now that we have 6x square minus 9x minus 15 plus 2x square minus 9x plus 10 plus 5x plus 26, and you all know what we have to do next. Basically just take all the common terms at one side and just subtract them, just basic maths here. There you go, after simplification I get 4x squared plus 5x plus 1, and again we can see that we have a second degree polynomial, and we can convert it into the first one by just using our discriminant rule or just plugging in the values in the calculator, as I told you earlier. So I'll be getting, there you go, I get 4x plus 1 and x plus 1 as my roots, you can say. And the other step is to just simplify further and just cancel out the like terms, which I can see x plus 1 and x plus 1 on the opposite side. So why don't we cancel them out? So after cancelling them, the final product is, there you go guys, that's our first answer there, 4x plus 1 upon 2x minus 5, and we have simplified it. As you can see, our a value is 4, b value is 1, c value is 2, and d value is 5. And now moving on to the b part. The b part states hence find f inverse of x. So we basically have to do composite function, the inverse function of f, which is given f of x equal to 3, and we simplified it. So what I'll do is I'll just take inverse of the simplified version here. They're asking us that, so let's get started. Now to take the inverse function of this, what I'll do is I'll just make x the subject here and change wherever I see x as y. So after rewriting, we'll get perfect, we get x as a subject here. Now to remove the fraction, I'll multiply everything by 2y minus 5, Now what I'll do is I'll just multiply the bracket and multiply everything with x, so we'll get 2yx minus 5x. Now I'll just bring 4y here to this side because I have an y here in that side, and I'll just take 5 minus 5x that side. That will become positive, so that will become 2yx minus 4y equal to 5x plus 1. Now uh, as you people can see that we have both y's here in the same function, so we can take a common factor out of it. So we'll take y as a common factor, and we also know that 2 is divisible on both sides, or I'll just take y as a common from there you go. As I've made y as a subject here, to make the y as a subject, what I'll do is I'll just divide 2x minus 4 from both sides, so our last product will be, there you go, y equal to 5x plus 1 upon 2x minus 4. That's our f inverse of x. That's a final product. That's 2 marks done, 4 marks done from the A part, that's 6 down and 2 more to go. So that C part is find the domain of f inverse. Okay, just let me clean this out. So to find the domain of f inverse, so to find the domain here, we should know the range of f of x. So the domain of f inverse equal to range of f of x. If you have studied your functions in P3, you will be familiar with it, that if we are finding the range of something, that's the domain of f inverse, so that's opposite of each other. So we know that x is greater than 4 here, so when we plug 4 here in this part, in the A part we found, we'll get a value of 17 upon 3, and that's our y value, that's the range. So one range is be done, and that's the domain of f inverse. And the second one, if you plug in, you'll get a 2. So 17 upon 3 is 5.6777, that's bigger, and 2 is less than, so we can write it as, there you go, that's our final answer. 2 is less than x is less than 17 upon 3. Keep in mind that we are not finding the range, we are finding the domain here. So the domain is the x values and the range are the y values here. So if you people are wondering how did we get 17 upon 3, I'll just show you now. If you all know that our a value was 4x plus 1 upon 2x minus 5 upon simplifying, so and they said that x is greater than 4. So if we check the limits here, I'll just plug 4 here to get a range for f of x. So our final product will be 17 upon 3, that's the domain of f inverse. Basically originally there was a range of f of x, but that equals to the f inverse domain, and that's our final answer. Thanks for watching guys, stay tuned for more videos from this series.